Okay, the stream is now starting, right? So I'm about to switch to my display, and we're going to start programming, right? So today's objective, as the title says, this time I had the sense to properly set the title before the live stream. Today we will be trying to draw lines, right? And from there, it's just a natural extension of the logic to be able to then draw shapes, right? And pretty soon at that point, we have a pretty good little like MS Paint clone, nearly, right? If I would just add some UI, right? And maybe we'll do that, but we're not going to go that far, right? It's more just like a tool to help draw these pictures as you see fit, right? Educational tool. Maybe if I feel like it, because I have noticed that there are some like drawing programs like so-called lightweight drawing programs on Linux that are not exactly very good. For example, I don't like Pinta, but to be fair, that's only because Pinta has scaling problems on my computers. So I have a 4K monitor when I'm using my desktop, and my laptop has a 2K monitor. The UI doesn't scale properly, and then I found, especially that on KDE with this laptop, it has issues. So maybe it would be cool to make a very lightweight tool like MS Paint. I don't think that sort of thing is exactly that hole is being filled by any particular program. Uh, I don't think that using GIMP or Krita is exactly um, a stand-in because MS Paint is not a large program. MS Paint is a very simple, basic program, right? So for simpletons like myself who are not particularly like artistically inclined in that sense, especially like computer-aided design, um, it's not appropriate to just say just use GIMP, right? Like I don't, GIMP is a big program. GIMP is not just for little things like that. Anyway, the code is not going to write itself. Let's go ahead and write into this, right? Um, so we have to go into the uh, C implementation, right? And previously, then, yeah, so we'd have this draw line, right? Um, and actually, I would like for this line at some point to also be able to handle diagonal lines too, right? And it's really easy to determine if the line is diagonal, vertical, or not, right? I might not even require this direction attribute because you can infer. Um, so I'm going to give it like basically an x2 and an x1, and a y2 and a y1. All right. Well, this is literally how we calculate the slope of a line. All right. But what we already know is that the slope of a horizontal line is constant. There is no slope. It doesn't increase at all. And a vertical line has undefined slope, right? But that's really easy. We don't even have to worry about the slope in that case. Immediately, a vertical line can be detected if the start column is the same as the end column, right? Okay, that's a vertical line. Similarly, a horizontal line is if the if the start scan line and the end scan line are the same. So there's no need to change any of that, right? Um, if those two are not true, so we can have like an if else, right? Um, and then the final else, is going to be the diagonal case. The diagonal case will be obviously these two are some combination of those are different. Um, and it can't be zero. It's not possible for it to be zero because y2 minus y1 cannot possibly. Well, y is in the top, right? So division problem. And the division problem in the bottom can't ever be zero because we would have already checked if the column is the same, right? So we're good on that sense. So actually, cool. So with that realization, I'm going to remove this. I'm going to require that. So the user is not going to specify like a length attribute. Instead, they're going to specify um, the starting row, right, and then the end row. But honestly, at that point, why don't we just call this like x1, right, x2, right, and then we would have y1 and y2, right? Um, Now this is kind of awkward because y2 is the scan line. Anyway, so I think that's all the information we need. We need the BMP, to which we're going to write this data into its a pixel data buffer, and we need the starting and ending coordinates, um, and then the color that the line should be, right? And later I can actually extend this to have a gradient, right? Um, and I can also send this to have the width, right? Now, width is obviously very easy for vertical and horizontal lines, right? We're just going to add additional pixels above, so uh, on the next scan line up or down, right? If we have to define that, I don't think it makes sense to do. For example, width 2, should it put the additional pixels above or below? Right? Width 3, should it put the 1 pixel above, 1 pixel below, or 2 pixels above, 2 pixels below? I'll have to standardize that behavior so it's not like so it's not unpredictable, right? But that'll be the design decision for later. Right now, we're just going to go ahead and just get the lines working in the first place, right? So the first thing about which we need to concern ourselves is, and again, so actually this should return a uint8t pointer, because we're going to return a pointer to um, the next pixel, which can be a little bit weird because it was much more easy to understand than when we were doing the previous function where it's placing a pixel at a coordinate. This one's a little bit more weird, but I think it's really just like where would you, if you were continuing the line, where would the next pixel be placed? So in the vertical line, it's going to be somewhere on the subsequent scan line. In the horizontal line, it's going to be in the subsequent column, if there is space, right? And the vertical, the diagonal line is going to be as if you were continuing the slope, right? Anyway, let's check if the BMP is null. If the BMP is null, that's a problem. There's not pixel data for us to be able to address, right? So what we'll do is we'll print the standard error and say, where will it be placed? What do you mean? So a BMP image is defined in terms of scan lines, right? Um, okay, so somebody in the chat is asking where will it be placed. The BMP image is defined in terms of scan lines, starting from bottom to top, and then there's columns, right? So you could think of it as a grid, like when you use grid paper, right, in like math class or an engineering class. Um, and so it's going to be placed in the particular pixels, right, to the grid. There, the image is just a grid of pixels. Now it's a little bit weird because each pixel is 3 bytes because there's a green, a red, and a blue value that make up the pixel. But so where it will be placed is in this unsigned 8-bit number. It's a buffer that's full of those, and we're going to write values there. We can determine the offset based on the properties of the image, right? Because it's a one-dimensional buffer. We're not doing, there's no need to abstract this. This is very simple. And even a two-dimensional buffer can really be thought of a one-dimensional buffer just with all the sub-buffers of the 2D buffer that concatenated together, thus forming a one-dimensional buffer, right? Anyway, okay, so in this case, we're going to return null because there is no pointer. There's no offset to be used, and that's how you know if the if you should not proceed. You check your return value to be null, right? Okay, so now the next concern is that x1 has to actually be a column within range. So x1 can be 0, that's okay. Um, because we're still using computer counting. We're not using like human counting, so we're not starting from one. Um, or maybe we should, shouldn't we? Let's see. What is the logic of this one? So this considers scan line 0. So I think we need to use like 0. Yeah, we're going to use a regular origin. Okay, so um x1, so these are all allowed to be equal. And even you can say a line, weirdly enough, in this, because when you take math class and it says like what is it, you know, when we're taking graph theory, it said like a tree can, like, a leaf on its own can be a tree, right? And the definition of tree and forest gets really crazy. So I think it's one of those things where it weirdly overlaps, where just one pixel could be considered a line. So I'm actually going to even allow for x1 to be equal to x2 to be equal to y1 to be equal to y2. That's fine. All right. Okay. So now then, what we're going to do is and if you want a yeah, so what I want to do too is maybe you're defining your line backwards for whatever reason. Right? Let's say you want to draw, instead of like from right to left, you want to draw from left to right. Now, I think that's kind of stupid, because if you really wanted to, you can, if you can draw from left to right, you can draw right to left. Actually, so I'm not going to even bother to handle that. Or maybe, no, I have to. Basically, I think if x2 is greater than, uh, hmm, how does that, does that confound the diagonal line logic? It would. You still have to be allowed to do that. Okay, that doesn't matter. All right, so anyway, let's just go. Let's just figure out what kind of line we're working with, right? Okay, so a horizontal line is going to start on the same scan line and end on the same scan line, right? So in this case, um, we're talking about the y value. So if y1 and y2 are the same, then we're dealing with a horizontal line, right? A vertical line, similarly, then, um, oh wait, I'm tweaking. Eh, yeah, let's just go ahead and put some header. I'll split some comments off this. So X going across is the column, right? All right, there we go. Okay, so yeah, if the start scan line is the same as the end scan line, then it's a horizontal line, right? So it's going across column. Um, if it's a vertical line, it's going to be in the same column the whole time. So this would be if x1 equals x2, right? Um, and I wonder if we can do that really quickly, actually. Eh, whatever. I don't need to like do a hack on a little thing like that. And then basically, and then otherwise, we're dealing with a diagonal line, right? Okay, so let's just do the horizontal line, right? So all we're going to do is we're going to get that scan line. So, well, first, okay, so regardless of what we're doing, I need to have a scan line pointer, right? And as we know, the scan line pointer is going to be okay. So another thing too is the BMP's pixelated can't be null either. Just realize that. By the way, God of Gen Z, you're in Nepal, right? Nepal is undergoing an interesting time right now. What is your experience? You live in Nepal. What is going on right there? I've heard that there's been a sort of revolution. No, is that true? Okay, so since the start scan line is y1, we're going to do y1 times BMP uh, width in bytes with padding, right? So if y1 is 0, aka the first scan line 0, then this we're just going to start at the first scan line with the pixel data, correct? Right. But if it's 1, we're going to skip the first scan line. So this is the logic there, right? Bro, we cooked our government, dude. I saw some of the videos, man. My apprentice, she's from Nepal, right? I can't remember where. Lalitpur. I don't know how to, I can't really speak Nepali. I've learned a few words. I don't know if it's this one. Probably spelled it incorrectly, but something like that, right? And I've seen, dude, it's nuts. I commend you guys. That's really crazy. It really is. I saw the what was it? It was the previous finance minister was like in the river. I've also heard that you've the first ever prime minister elected over Discord. Well, I'm very hopeful for the future of Nepal. It seems as though young people are taking a very active role in politics, and I think that's very good, especially to establish a government by the people for the people. So wonderful. I'm glad you're safe. It's I saw when I first saw some of the footage, I was I was I was scared. My apprentice, her family lives in Nepal, and I was hoping that they're still safe. Amidst everything that happened. But excellent, very good. Jeez, 50. This is so what? This is in relation to the This is in relation to the what do you call it? Those protests. No. Now I know the scanline pointer can never be null, but just for sanity, I'm going to check in case the scanline pointer is null. Right. Okay, so I'm going to consider that an erroneous case, right? Okay, and column is not a big deal at all, so we're going to ignore the column situation, right? Okay, so now horizontal line, right? So now that we have the scan line pointer, basically what we're going to do is, okay, so here, this is where I will handle the case of like drawing from left to right versus right to left, right? Here's where I'm going to check if x2 is greater than x1 because I'm just doing this in a loop, right? Um, so the loop has to be growing towards an endable point. It has to actually run. And it's going to obviously use x1 as a starting point and x2 as the ending point. But that becomes broken if x2 is less than x1, right? So that has to be addressed. The old prime minister ran away. Bro, where did he go? What the hell? Okay, so if so, I'll have to do a swap here, right? Um, so I may as well just put it on the stack now, I guess. I don't know. So if x1 is greater than x2, eh, then I'm just going to swap them around, right? So this is where I'm going to put the UN32T. So swap. Okay, so then x2 needs to become x1, right? Okay, so we're just swapping the values, right? Now x1 will be the lesser and x2 will be the greater, right? So now what I'll do is I'll just do a simple loop. Or maybe I could even do I even need to loop? Because I have to uh is memset faster here? The problem is memset is awkward because I need to set potentially differing values. Right. Okay, cool. So I guess here's what I'll do, right? Um oh, so another thing too is we can't be violating the width and the height, right? Okay, so if the start scan line is neither the start scan line nor the end scan line can be outside the height of the image, right? And neither the start column nor the end column can be outside the image, right? So if y1 is greater than or equal to BMP height, right? That's a problem. And again, it can't be equal to the height because we're counting from zero, right? Where I'm out, keep up the good work. Thanks for watching. I hope you'll continue to watch later. And yes, I will continue. Uh, and yeah, good luck out there again, for real. Uh, amazing! You're witnessing amazing times right now. So thanks for watching. Seriously. Nice. Okay, so similarly, the end scan line also can't be outside of the boundaries either, right? In which case, let's go into print this. It's really doing all the same stuff, but just this one is a little bit the error must be different because the error is naturally different, right? So because we're not talking about the starting scan line now, we're not talking about Y1, we're talking about Y2, and we're talking about the end scan line, right? Okay, now similarly, the columns cannot go outside of the boundaries either, right? So if x1 is greater than or equal to the width, that's a problem. And if x2 is greater than or equal to the width, that's a problem, right? And honestly, I can just probably copy this error text and just return statement because it's all about the same thing. I just have to change the particular wording in here, right? Okay, so now we're talking about the ending column, right, which would be x2, and it cannot be greater than or equal to the width of the BMP picture, right? And again, now we're talking about x2, and okay, what is that? Get off my screen. And the width of the BMP. And similarly, now here we're talking about the starting column, which would be x1, can be greater than or equal to the width of the BMP picture. Kind of begins from 0, so the first adjustable is column 0. And we're not going to talk about the bottom scan lines, it's no longer relevant, right? Alright, so x1, and then we talk about the width, right? Uh, And honestly, we can just kind of go ahead and put all these errors right here, right? And let's kind of label this section so it's easier to gloss over it, right? Very cool. All right, so now we know that the counting will be proper, right? It will be forced to work from left to right because we'll swap the values of x1 and x2 if x2 is less than x1, right? And we know that neither x1 nor x2 will be outside the boundaries. It can't be -1 because it's an unsigned value, uh, and it can't be beyond the photo in terms of its columns because it's already been checked that they're not equal to or greater than the width of the picture, right? Okay, so we're going to have I is going to be equal to x 1, right? I needs to be less than x2, and we're going to increase I, right? And I don't think, no, we do need to do this, right? Okay, so then scan line, so the scan line pointer um, 0 needs to get set to, so again, it's BGR, right? So it needs to get set to the blue value. Then with an offset of 1, needs to get set to the green value. And then with the offset of 2, needs to get set to the red value. And what we're going to do is 3. I believe it needs to be 3 times I, right? So 3 times I plus this, right? All right, so we need another variable, right? And this would be a. I'll make this let's make this a size t. I don't really know how big this needs to be. It's a temporary variable anyway, though. So um, so this is the pixel offset, right? This is talking about you know, uh, offsetting by 3 bytes, right? And right now we'll just initialize it to 0, right? Now at the start of each iteration, we set pixel offset to um, 3i, right? And then it will be pixel offset, right? Because I is going to start. Oh shit! Wait, no, I'm losing my mind. Um, no, it yeah. So shit. Because I is not starting off at 0. Oh wait, no. Okay, well again, if we want the 56th column, right? Okay, so we're back to drawing, I guess. If okay, so if x1 is, let's say we're drawing a line from column 10 uh to column 32, right? So the length of the line would be 22. And we're going to have I equals x1, right? I is less than x2, and I increases by 1 each time, right? Maybe actually I need to be increasing I by 3, I guess. But anyway, so if the pixel offset, if before this loop, I know that's not the proper code, I didn't put like the thing, this is kind of like pseudocode, just in like C-ish format, right? So if the offset, and then I set the pixel offset equal to if then this value would be uh 30, right? 30 bytes. Yeah, and that's correct, right? So then if I do yeah, that's correct because we would be doing it at byte 30, which is where 10 starts, right? So then similarly, plus 1 is going to be the green, which would be at byte 31, which is where we want it for green, right? Everything is in terms of the next 3 bytes. So pixel 11 would be starting at byte 33, right? So then, and then the loop would go back, right? Now, since I would be 11, right, for as in for the 11th column, then this would be 33, and this would be putting it at offset of 33, which is correct. This would be putting it on offset of 34, 35, right? And the next loop is 12, and this would be putting it at 36. Okay, so that logic is correct, right? So then it would be pixel offset um, plus 1, right? And then pixel offset plus 2, right? And that's it. And then we're fucking done. Right. Now the problem is, eh, if if this ended at the boundary, where do we say the next line would be? I think the answer is not null. Um, I don't know what the answer should be. Maybe there can be an additional status return. I guess I'll just have it return the next line. I guess if you wanted to keep drawing this line, you would have to go to the next line. It's kind of weird behavior, but I don't know what else to do because returning null is kind of what it does when something went wrong. I would need, if you wanted to know if it went wrong or not, uh, well, it didn't. And so in this case, it didn't go wrong if you finish at that boundary. It went right. It's just that the line wouldn't be continuing, right? So I think this one needs to also return a special status thing, right? Okay, so let me save what I've been doing right now. Let me start a new tab, and I'll open up the header file, 'cause that's where this type of stuff is. Now, we don't care about this guy anymore, and since I actually removed that, this is not here, so this function description needs to change, right? So then we have x1, right, x2, this would be y1, right, and this would be u32t y2, right? Okay, so with that, and now this is modified. Okay, yeah, so it doesn't, oops. This doesn't return size t, it's return the u8t pointer, right? Um, and this for now, I'll change this one too as well. For next pixel would be, this needs to return a status, right? So this needs to have an enum status, right? So I think, what did I call it earlier? So I'm on line 55 right now. Easy BMP status, right? Um, okay, I don't think there's really a better way to describe that. It's the line ends at a boundary, which is why there would be no pointer. So yeah, let's just call that. This is going to be a pointer to an easy BMP status, right? And that will help to understand what is being returned. Okay, so now I can go to my previous tab. And now this function, of course, needs to expect a status pointer. Um, oh wait, this is for the, I'm tripping. This is the put pixel coordinate function. I'm talking about the draw line, right? Okay, so okay, and of course now that messed up this. So I need to move all this over here. There we go. Even though I used like multi-line edit, it still didn't exactly do what I wanted to do, but whatever. Eh, okay, cool. So yeah, so the status just helps to disambiguate. Yeah, because I'm not going to assume that your next task is to draw a line on the next scan line. I'm not going to do that. So I'm not going to have it return the next scan line. I'm just going to have it return null, right? So now again, it's possible that well, the greater one has to be okay. Yeah. So if x2 equals width -1, right? Then I'm going to return. I'm going to set the value of the status, right? Line ends at boundary, and I'm going to return null, right? Otherwise, should just be status okay. All right, and I'm going to return um, a hmm. So does x2 have to be inclusive? That's where it ends, right? Um, yeah, otherwise you'd have to be putting a value that you're not allowed to do. Okay, so why need this needs to actually be less than or equal to x2, right? Okay, cool. So then the next pixel would have to be greater than x2, right? So it would be 3 times x2 plus 1. That's where the next pixel would begin, right? Um, well, also it would be, okay, so the offset would be this, right? This would be the pixel offset, right? We will return the scan line pointer plus the pixel offset. And that, now I'm returning a pointer, right? And yeah, so we can take from that scan line and we want to move over that many bytes, right? All right, cool. All right, I'm chilling with that. All right, so just like that, we got the horizontal line done, I think. We'll have to test it, right? But yeah, okay. Um, cool. Now let's handle vertical lines, right? So scan line 0 is okay. So x, yeah, we're talking about okay. So this means that now the problem would be again. So I guess we're drawing the line from top to bottom. So if if so, what's the problem? I'm sorry, I'm just this is just weird. It's a little bit weird to think about. This is all brand new sort of thing to me. Okay, so the problem is since we're building up, there's a problem if y2 is less than y1, right? In other words, if y1 is greater than y2, we need to swap them, right? Um, and since these all use a swap, I'm going to just go ahead and put that there instead of having like the swap get defined a bunch of times, right? So then swap is going to be equal to y2, right? Y2 is going to become y1, and y1 is going to become the swap. Okay, so now for uint, what did I do? Oh, why did I do it? Yeah, okay, no, that's not correct. Uint 32t I, right? Because I is basically just iterating over the columns, and columns are defined by at most uint 32t. Right? So similarly, for uint 32ti equals y1, right? And I has to be less than or equal to y2, and we're increasing I. What we're going to do is set memory. Um, and so, yeah, also, I guess then the pixel offset can also be here because we're kind of using it like all the time. right? Okay, so pixel offset's already 0. In this case, pixel offset is still real, um, because the scan line we pick can also still be indented over, right? So we still have our scan line pointer, but it's going to be moving around, right? So that will be at the end of each function call, I mean, or at each iteration of the loop, right? But anyway, so the pixel offset is still going to be 3 times I, right? That way we know how far along the scan line to go. And then we'll do the same thing with increasing by, we still need to set its values, right? The thing is that just we're going to get a new scan line, right? So now we're doing it on a new scan line, right? And that way, thus we're going up, right? So scan line pointer is going to get set to blue, right? And then of course, +1 is going to be set to green. This will be set to red, right? And now we're not drawing across that scan line anymore. Um, oh, you know what? The pixel offset is a constant value always. Um, right. The pixel offset is always going to be um, 3 times the start column, right? And the start column would be x1, I believe. Yeah. I could also put x2 if I wanted, but they're exactly the same, so it doesn't matter. Okay, pixel offset is constant. Okay, so then we'll just get a new scan line. And so I is going to go up now. So now it's going to be um, I times width in bytes with padding, right? And I'm just going to do the obligatory check that scan line pointer is not null, right? Well, that will never be null. That's straight up arithmetic, right? The problem is not that it's null. It's more that the scan line pointer cannot be greater than or equal to the image size in bytes, right? Because then we're going outside how much memory was allocated, right? Image size in byte is also going to include padding, right? Yeah. Okay. Cool. So yeah, the scan line pointer can't be outside of bounds, right? In this case, we need to change status, right? Um, and so it's still this is basically the same thing. The line would be ending at a boundary, right? And then we should just return null. Um, cool. Well, that's drawing the vertical line. I guess now we'd have to do a similar thing, right? So now we have a case where it ends at a boundary again, right? And so instead of basically copy that kind of shit I put up there, so case. line ends at boundary. So in this case, this is if y2 is equal to the height minus 1. We know that it's not a problem going outside because we had already encountered the other thing, right? And in which case we're going to return null. Otherwise, what the fuck? Okay, I guess it was kind of like copied my thing. That's weird. Okay, so the status would be status okay. And we're going to return the pointer to the next pixel, which would basically just be the next scan line at that offset, right? So, um, let's see. So we're going to set, no, pixel offset is still the same. We're supposed to see a new scan line pointer, right? Oh, uh, no, because that's when the loop, that's how the loop continues, right? Um, hmm. Okay, initially the scanline pointer is already correct, right? Um, yeah, that's weird. The scan, hmm. Yeah, it's slightly awkward because we're going to, okay, hmm. So really this should be here, but it's kind of dumb because the first time it's already defined, right? And so we're just doing that again. So I guess I can kind of, do the first one first, right? So it'd really be more like for +1, I guess, right? It's kind of weird, but it's just because scanline pointer is already defined, so like I don't know what the point of getting that again is. All right, cool. Um, yeah, and then we continue, right? Yeah, that's fine. And pixel offset is constant anyway, right? It still needs to be here, so that's fine. Yeah, that should be fine, right? And now this way, this is not getting done like twice, right? Okay, cool. So then the scan line pointer would be this would be come on y2, right? So at y2 plus 1 with invites with padding, right? Okay, now the diagonal line. Now this is the one I'm kind of scared to touch, to be honest. That's because diagonal lines are cool when we're talking about a continuous, thing with infinity. But we have to draw on some actual pixels, right? So I think somebody, I was watching a video about this, and basically the line is pretty much going to tend to fall uh, within several pixels. So typically you'll be really drawing, the first pixel is okay, but in every other pixel, for the most part, you'll have to kind of draw 2 pixels, right? So there's this idea of what the Bressenham is it Bressenham, Bressenham algorithm, and then I believe was it Zhaolin Wu? He has an algorithm that expands or improves the Bressenham algorithm by um, doing a way of anti-aliasing, right? So what we want to do here is probably visualize this. Um, Although I want to, let me see. Can I find like a simple tool for drawing on a grid, right? Well, first, here. Let's go. Uh, there we go. So let's just have a simple line, right? So let's say x1, we're going to start at 0, and we're going to move over like, that would be a long line, right? 15. And let's have y1 be, so let's have it be a line going up. Why not? Y1 will be 0, and Y2 will be, I want it to go up. Well, let's look at that right. Okay, so the slope is 1 at that point. I think I don't need to walk through that. And if it's Y equals mx plus b, so then our coordinates would be, um, so yeah, Y is, x plus and what's Y, b is the y-intercept, right? 0. Okay. Um, so for x in range x1, x2. So the slope is equal, right? So this case is fine because we're only so we know exactly where to place it. But now let's do a slightly harder example, right? So I'll still keep x1 is 0 and x2 is 15. But let's say that y is 32 now, right? So now the slope is it's that fucking number, right? Um, so now the coordinates will be mx plus b, right? So slope times x, and the y-intercept is still 0, right? So it's just this for x in range x1 to x2, right? Okay, so 2.1, right? That y coordinate is overlapping, right? A part of it is touching. How do I show this? Right. Um, there's no fractional pixel, right? So this means that it's touching um the pixel at y equals 2 and a little bit of the pixel above it, right? So we would be drawing 2 pixels, right? Basically, the floor and the ceiling. So for example, here. So I'll make a touched pixels equals I guess do I need to import math from like from math import floor seal, right? Okay, so touched, that's kind of a weird. Anyway, touched is going to be the floor and the ceiling of every coordinate, right? Okay, so we can see that every pixel is touching, uh, or every iteration is touching two different pixels, right? So when we draw the line, we have to do both of them, right? Except the first pixel is not touching more than two; it's just touching that area, right? Um, so I don't know. Is there like a way I can? Is there like a little like grid drawing app or something? One sec. Let me go search for like a grid drawing app, right? Okay, I guess I found something kind of close, right? So let's just put my coordinates on the side, right? So I don't really know where this begins. Does this tell me where I'm at? Conceptually, so what I'm at y equals 15. So if I scroll down a bit, okay, well, I don't want it to be too big. Here, let me just draw my graph, right? So I'll draw this line from, okay, I guess I'm not drawing a line. Ah, okay, let's see. Let's make my, well, I'm done drawing the line now. Here, let's make the stroke black, right? Okay, this program is quite hard to use, but whatever. I think you got to click and then you start going, all right. Okay, so I'm going to, okay, so 0, 0, let's just say this is 0, 0, right? That pixel right here. Um, so we're talking about from the left, right? Where touches left is 0, right? So for example, I'm going to say that it's a 0, that's 1, that's 2, that's 3, this is pixel 4, pixel 5, pixel 6, pixel 7, right? Um, so I'm going to draw a rectangle, right? Okay, so pursuant to this, we have 0, 0, right? So pixel, it's the same. Then we would have pixels 2 and 3 are being touched, right? This is, oh, okay, so I didn't do my, one second, let me adjust. The coordinates is only telling you the y, not the x, right? So coordinates would actually be, I put another parenthesis. There we go. Okay, so yeah, now we have our thing. Right. Um I believe those are my coordinates, right? So now touched would be um this is gonna be a little bit weird. So we're gonna have like a tuple with a tuple inside, right? So and that will be the y pixels that it touches, right? I guess really it could touch more. Although one x value seems to always correspond to some like fractional y value. So let's just say this, right? For x and coordinate in zip, uh, range x1, x2, right, and coordinates, right, and zip those together. Must be a real number, not a tuple. Oh, I see. This needs to be the second coordinate for y, right? So put one. So I'm just passing it a tuple. There we go. Okay, so okay, let me just. That's a little bit hard to read. Let me just list them all, right? So okay, there we go. So we're going to touch x at 0, and then the y coverage is 0, 0, right? Then at x1, we're touching both y is we're touching both. Geez, there we go. Pixels uh 2 and 3, right? Then we're touching both pixels at pixel 2 x. We're touching both 4 and 5, right? And then we're touching both 6 and 7 at 3. And then we're touching both 8 and 9 at 4, right? So this is, how we would draw that line, right? Um, I guess, for example, let me try to show this by putting the coordinates, right? So let me try to draw like a circle at 0, 0. In this case, I guess the fill needs to be a different color. Let's make it like red, so it's kind of like just glaring, right? Well, I think it'd be huge like that. Whatever. Okay, so that's 0, 0, right? And I'm going to like 15. Oh my god, this thing is so bad. It just took me out of it. Is my drawing still there? Okay. There we go. I still don't know how to still don't really know how to move across. Okay, wow, this thing sucks, doesn't it? Oh, is this how I pan? There we go. If I still need to zoom a bit, don't I? Because I don't know where the hell I'm at, right? So this would be 8. Wow, this is really hard to do. Anyway, as we can see from the coordinates, right? In this case, this is only really touching 3, just a little bit, because this really is supposed to round down. So the idea would be that this should be anti-aliased, I believe, right? I didn't actually watch the whole video, uh, and I'm not going to watch it now because that would be uh, like disgraceful, I suppose. It's not appropriate use of the viewer's time. I'll have to watch that on my own time a little more. But my understanding would be basically that we would do like a more opaque pixel, a less opaque pixel, a lighter pixel that blends more into the surrounding area. Um, because of um, because it's really not supposed to be there. It's only just kind of touching it, right? Um, so let me just reset this. Right, there's a stroke and there's a fill color. Okay, so hmm, can I increase? So let's increase our rhythm. All right, and then I'll use this to pan over. Okay, I'm getting the hang of this program, I guess. All right, so then this pixel really should be um, more oh, should be really more kind of like aliased, right? And so just continuing this trend, I know that these pixels here should be aliased, right? And then because of this, it's going to look a little bit more like a natural line if I zoom out. So you saw I zoomed out earlier, and it looked like a diagonal line, I guess, but it was kind of like janky, right? So I think with this is going to show kind of the idea with the anti-aliasing, right? So I guess now if I were to zoom out, I think it kind of looks like a line, I guess. Whether it looks like a line or not, that's basically what I'm going to try, and then I'll adjust it later. Um, if I learn the algorithm more properly, from there's a video by this guy called No BS Code, right? As far as I understood, um, the fractional part of the touching is how you determine um, what do you call it? How opaque it is, right? So, um, if it's 2.8, right, it has a greater fractional part, right? Um, so it would be touching the Pixel 3 would be more opaque, and Pixel 2 would be more transparent, right? Um, eh, so I guess the idea would be to do like a loss to opacity based on how near uh, the pixel is. So the 2.8 is only 2 away, so its opacity would be like 80, right, percent. Uh, the Pixel 2, the fractional part is zero point 0.8 away, right? So it would have like 20% opacity, right? It would be mostly transparent. That's what I'm going to try right now. I don't have much time anyway because my girlfriend will be returning from work. She has started her second job, and they scheduled her late as hell today. But we have to make that money, so LOL. Yeah. So what's gonna happen is I'm just gonna kind of do like a little thing, a little silly line diagonal thing with maybe a little bit of like a like a first attempt, just kind of winging it, anti-aliasing, and then we're going to come back some other time for another live stream. And in that live stream, I will hopefully be more informed by these algorithms, and I will refine what I'll do here. So, now let's just go ahead and do some basic having a sip of my cola. One sec. Went to the gas station and got some cherry Coke before I started this. Okay. So diagonal line, right? Um. So this is still iterative, but at each iteration we're going to get our at each iteration we're getting our x at y, right? Well, obviously then we need our slope, right? So here, and slope is going to be a double, and that's going to be y2 minus y1 divided by x2 minus x1, right? More specifically, so if x, so let's see here. Well, in other words, if x2 equals x1, right? That's the problem. Uh, but haven't we already accounted for if x2 equals x1? We already did that here. So it's impossible that this happens, right? So we already know this can't be happening. We already checked this, right? So we need to so we already have the slope, right? So then each y coordinate is going to be um, this guy, right? Um, x still has to increase by 1. Okay. So what we'll do then is well, I guess we're iterating from x, right? So some u in 32t I is going to be equal to x1, right? The starting column, right? I is going to become less than or equal to x2, and I will increase by 1, right? And what we'll do is we will get our relevant values, right? So, yeah. Okay, so in course, then this means we need to include city math.h, or is it just math.h, right? And then y is going to be equal to the slope times x plus b, right? Uh, and we need to know what b would be. All right, so b is when x equals 0, right? Because b is the y-intercept, right, where we touch the y-axis. Um, so first we solve for b, right? So then we'll do, I guess b is also potentially a float, right? Um, so that would be a y equals 0. So 0 minus, okay, here, fuck. Sorry. And y is 0, so we can just ignore y, right? So then b would be equal to x, well, negative x, divided by m, right? We would, oh, not even that. Um, b is equal to uh, 0 minus mx, I guess. Okay. Well, um, what, that guy, I guess, right? Well, first, let's ensure that we're drawing always from the same direction. So here now what we care about is x2. Hmm, Oh, yeah, we're iterating over x, right? So yeah, we just want to make sure that so if x1 is greater than x2, right, we're just going to swap them. Now, did I? Yeah, you always set swap first, right? All right, cool. Let me just check. Is that true? I'm looking really silly because this is like basic math, but I haven't really had to do like slope intercept form in a while. So sorry. Please ignore my please ignore my lack of education, I guess, as I would appear right now. Now let me go look this up. And I do not have the humility to look it up uh, while sharing my screen. So give me a second. Sorry. At least in my embarrassment, I used the bathroom as well, so that whole time was not me figuring out. That whole time was not me figuring out uh, what the equation I used to do in middle school, right? Finding the slope. I was just confused by it because I felt as though if I'd always just substitute zero, I'm just gonna get zero all the time, right? And just have y equals b. Surely that's not correct. But then I wised up and I said, okay, you need to use 2 points, right? So, having more cola. Alrighty, so let's continue, why don't we? Alright, so b is equal to y 1 minus x1, right? So a y1 minus mx1, right? So y1 minus the product of the slope and x1, right? That's b. Okay, so we'll calculate our y value at each iteration, right? Um, and then so okay, so we'll figure out what pixels are being touched, right? Um, if they're the same, then no pixel, then it's not a fractional number, right? Um, and all that, right? Um, so yeah, let's see. Uh, I guess then I also need hmm, uh, what do you call this? Yeah, these are the two pixels that are touched, right? You want it to be slightly brighter because I haven't added the alpha channel yet. So the number needs to become slightly brighter to appear more transparent. That's how I'm going to do it right now. Assuming you're drawing a dark line, right? Well, I guess an easy way to just assume is just to check uh, how dark the image really is, right? How dark your provided color is, because you can only draw in one color. So let's say if you've selected 255 across the board, then it needs to be getting darker, right? If you selected 0, it needs to be getting lighter. Um, hmm. And if it's exactly down the middle, okay, so I'm just going to arbitrarily set it then, right? Uh, if you are at 127, then it's going the aliased pixels are going to get lighter. Are going to get sorry. They can go what? They can go up, right? Because if you're between 128 and 255, you can't go up. You have to get you have to get darker. You have to get darker, right? So darker if on range, right? That's how I'm going to do it, right? So in other words, if you're drawing like a white line, the white line needs to become more gray if it's supposed to be like a little bit transparent, right? blending into what's around it. Um, and it needs to become lighter if a lighter gray as opposed to like a just darker gray if it's a darker color, right? This way it will be kind of blending in, I guess, right? Because presumably you're not drawing a white line on a white background, right? That is my idea. And I know this is not exactly correct, but this is what I'm just doing for now. I mean, honestly, it's either that or because even this live stream is titled, I'm only doing the vertical and the horizontal lines, and the next live stream is meant to be tackling um, the vertical lines. So I might just here. Let's just do this, right? Yeah. Well, here we'll just say this is unfinished, right? But I guess I still need it to return, so I'm just gonna have it preemptively return. I'm just gonna have it return null, right? Because I'm right now more interested only in drawing the vertical and the horizontal lines. I just want to see that it works at all, right? Um, okay, well in that case, let's see if my code compiled, right? Okay, so earlier I changed that to be uint pointer, right? So now it needs to be there. So comparison between pointer and integer, right? Yes, because I need to do the pixel offset plus the image size, right? Uh, the where the pixel data begins, not just that number, right? And x is undeclared, and that's true because I'm not using x, I'm using I in that case, right? Okay, so where am I going to? I'm going to lines 211 and then I'm going to lines 250, right? Okay, so that's that. Now I'm going to go to line 250. X is undefined because this really needs to be X and not I, right? Just to kind of follow the model, I guess, with the math, right? Okay, so now we can build, I hope. Cool way it compiles, right? And so in that case, then let me go ahead and change the drawing program, right? Uh, and now I don't need to draw pixel by pixel. Now I can just do lines, right? So so I need to do a status, right? There we go. We'll set the status okay by default, right? I'll give the pointer to status. I want it to start on the bottom scan line, right? Okay, so actually, yeah, here let's just draw let's draw a bunch of lines across, right? So for uint 32t I equals 0, we're going to go all the way to the top, right? So I needs to be less than BMP height, right? Yeah. And let's see, and then I'll just do like a. So I'm going to draw a few lines. I'll make them red. Um, okay, let's draw like a pseudo shape, right? Let's try a pseudo shape. So I'll make 3 lines, right? Um, Actually, it's 255 or 255. So actually, let's go ahead. Let's fuck it. Let's just go ahead and do 10 lines, right? And let's just make them black, right? So from 0, um, from I to I, because we're talking about X, right? No, so X needs to be from 0 to 255, right? And then we're doing from I uh, to 255, right? It's going across, right? So that's our X, and then we're doing it from yeah, I to I. Yeah, it's a horizontal line. Sorry, I'm like tweaking. I just finished doing this. And so this is a horizontal line. Then you need to give it, making it black, so these will all be 0 pixels, right? I guess, oops. I guess then we're just continuing this. But now I won't be 0. I is going to be more like 255, and then we're going down, right? Okay, so let's just do 245 to 255. And I'm still going all the way across, and we're doing it on this Y selector, so that's fine. Then we'll draw a black border on the right? And that, oops. And doing so will just be a matter of changing our parameters, right? Okay, so because now we're going to draw it, so if it's on the left, then we're going to start at column 0. And if it's a width of 10, we're going to go from 10, right? Um, but now we're talking about our X position, right? So our X position is going to be from 0 to 55. And then our Y position, oh no, our Y position stays the same. No. Ooh, I'm losing my mind a little bit, aren't I? Here, one sec, I just got a text. Let me make sure it's not my girlfriend saying she's already here. Let me just make sure the logic is correct here. So top, my X is going across, correct? Yeah. Okay, I see. X is not changing, right? So X needs to be 0 the whole time, right? And then we're going, um, yeah, we're going from, oh no, so I guess I'm iterating across, but I'm still drawing the vertical lines, right? So I'm going from a, okay, so my start and my stop X is still I, right? But now I'm doing it from my starting Y is going to be 0, and my ending Y is going to be 255. There we go. All right. Okay, and so, yeah. And my starting Y is going to be 0, my ending Y is going to be 255, right? Um, Now I guess I want to fill in the rest with, let's fill in the rest with, like, blue, I guess, but like a light blue, I guess. And so I'm gonna do this. I'm just gonna do a bunch of horizontal lines, right? So I don't need to do the top 20 or the bottom 20, the bottom 10 or the top 10. So what I'll do is I will start from let me see. I'm selecting my Y, right? So I'm going to start from the bottom to the top. So my uh, bottom would be 10, right? Because previously I didn't end at 10, I went up to 10, right? Uh, I is going to become less than 245, right? And I is going to increase by 1 each time. And I'm going to do a BMP draw line. All right, so my X position is always going to be uh, ignoring the 10 lines to the left and to the right. So I'm going to start at 10, and I'm going to go all the way to 245, right? It's my my start X, my end X. And I'm going to go from I to I. So it's a horizontal line because I'm starting at the same Y and ending the same Y. And I'm going to do, so if blue comes first, let's just do like, let's do blue all the way. But let's just turn these guys down a bit, I guess, right? So I guess I can just go to color hex, right? Let me see. Let's do like an RGB. What does that look like? Okay, that's pink and not light blue. So let's just go to this guy. Okay, this is 159, 197, 232 for RGB. So I'm doing 232, 197, 159. Yeah, 159. Oh, wait, well, okay, my thing takes RGB, but since since the BMP format is VGR, okay, cool. So this is made to be more human readable in this case, right? Okay, now let's write to line example.bmp, right? Okay, so I'm out line example, and I hope it works because otherwise I need to redo this, right? So let's do build lib again, and then build easybmp. And let's run easybmp. Okay. Well, now supposedly I should have drew a picture. So, oh, it looks like it worked, huh? Well, what do you see there? What I described, right? Isn't that cool, right? We're drawing pictures, right? So obviously it would have been better if I had a function to draw a shape, right? Um, but this is not bad. This is not bad at all, right? Like in a couple of lines of code, and it was don't get me wrong, I had to I had to think a little bit harder than I needed to, but a couple of loops and I drew these lines, right? And I made a little picture, right? That's I think that's cool. I think that's cool, right? Um, so yeah, well, I guess that kind of demonstrates the point I was going for with this. Um, I wanted as per the title, I wanted to draw horizontal and vertical lines, and I've added that functionality. Right now, it's just a matter of drawing. It's a matter of drawing diagonal lines, right? And I'm thinking maybe I might make a separate function because the function call you saw. I was trying to write it, and I was getting kind of tripped up, just thinking like, oh wait, am I putting am I putting the value here? Am I putting it there? I think it's weird thinking of it in terms of if I want a horizontal line, it's weird thinking of it in terms of which my ending y, because my ending y is the same as my starting y. I guess you could say, oh, you're overthinking, just write the same y, but clearly it's problematic enough where I was like, what the heck? But I think this is cool. I think this is cool. I drew a picture, right? And so similarly, if I wanted to make it like let's say I wanted to have I don't know, like a slightly darker borders. Let's say I wanted to have this color, right? Then I'll go ahead and just change the border to be this, right? So we're talking about 95, right? 118, 139, right? And I'll change these guys too to 95, 118, 139, and then this as well, right? 95, 118, 139, and then same here, 95, 118, and 39. Okay, so I'm going to compile it, and I'm going to run it again, and then I'm going to open up my file explorer, and oops, what happened? Hmm, why hasn't the color changed? It's still black. Did I mess up? I compiled it. It should have compiled to have these new instructions, no? Am I tripping out? I mean, these are the colors, all right? Wait, that's weird. Oh, I just built it, but I didn't run it. Wow. I'm getting tired. I guess you can see it's 1:34 a.m. I just made such a ridiculous mistake. I'm like, oh, why did my picture change? Okay, now I suppose if I run it, and then I open my file explorer, right? And I go to the photo. Okay, cool. Yeah, so there's something weird happening up there where hmm, what happened there? Ah, well, maybe something for the next live stream, a little cliffhanger for my show, I guess. Just being silly. Like, I do wonder what happened there, though. Um, maybe there's a scan line problem because I instructed it to write them all as that color, but there seems to be a little bit of black happening, right? Um, hmm, I wonder why. I really don't know. 255 should be the last acceptable column. Hmm. No, I think if I put, for example, 256, it's going to say you can't do that. Or is it because are these never touching where they leave off? I mean, this one leaves off at 10, right? And this one starts at 10, starts at 0, and moves on to the 10th column, right? Hmm. It's peculiar. Something is wrong with it, but I don't know what it is. Eh, oh well. Either way, it appears my tool is coming along nicely. It's just that when I use that color, something weird began to happen. Yeah, there's a little bit of weirdness happening at the edges, but this is in dark mode, which makes it harder to tell. Well, anyways, um, we'll see. You know, but development is going along nicely. I'm having fun with this project. We just drew some lines, so if I can figure out what's happening at the boundaries that's causing some strangeness, I can call the line function done, and I can move on to making shapes. I might actually do shapes before I do diagonal lines, although, for example, if you want to draw a triangle, you can. So it'd really be more like I'm just going to draw rectangles and squares only, um, which is not bad, but hmm, we'll see. I guess also there's room to argue that you need to draw the lines with width, but also then I could say, why don't you draw the lines with width? Um, And in the rectangles, we can concern ourselves with the idea of having a fill or not, right? We'll see. But I'm going to call the stream now. It's been 2 hours and 10 minutes. We did the lines, a little bit of a cliffhanger there on the what the hell is happening at the end of the file. But yeah, and then it's about to turn 1:40 a.m. right now. So yeah, well, anybody who watched live and anybody who's willing to watch this recording later. I thank you for watching this. I hope something was to be gained. I hope this was educational and informative. And yeah, well, as always, thank you for watching, and I'm ending the stream here.